Hey everybody, this video is going to go over logarithmic graphs, right? We've been looking at, what are logs, how do we evaluate them, how do we convert between logs and exponential expressions, how do we manipulate them with those properties that we talked about in the last video, condensing, expanding. Okay, these last couple of videos of the unit are going to focus on some more, applicable things, like the graphs of logarithmic functions and the equations with logarithms. So a logarithmic graph is very similar to an exponential graph. We're going to talk later about how these are actually inverses of one another. So they are going to look very, very similar. Okay. So if you think back to exponential graphs always had a horizontal asymptote, right? That boundary line. Well, logarithmic graphs are going to have vertical asymptotes. So the parent function, and we're looking at the graph of log base 10 of x here. The parent function, and it could be any base, right? It doesn't have to be just log base 10, but any of the parent functions are going to have a vertical asymptote right along the y-axis here, which would be represented by the equation x equals 0. So this vertical asymptote is only going to move if we shift things left or right, okay? With exponential functions, we said that horizontal asymptote moves if we have vertical translations, okay? Vertical asymptotes move when we have horizontal translations. So let's talk about the transformations of a logarithmic function. Now, just like we always have had, right? We have this value inside with the x, right? So inside of the log, if we have x plus some number, that's going to be moving left. X minus some number will be moving right. If we have that value outside of the parentheses here, okay, happening outside of the log, that's going to be your up-down, okay? And that's typical. That's what we've seen all year, no different. Okay. Also, as usual, the a value, so if there's a number in front of the log, that's going to control your reflections, your stretches, your compressions. So let's look at some examples of transformations. Now, I want to not only identify transformations, but also the parent function, and then, like we did for the exponential video, right, we're going to determine the location of the vertical asymptote. So for the first one here, my parent function is just log base 10 in this case of x. Okay? So parent function, I'll just abbreviate, would be log base 10 of x. So any other numbers you see correspond to some kind of transformation. So the plus 1 inside the log with the x is going to be moving it left 1 unit. The minus 2 that you see outside of the parentheses means that it's being moved down 2 units. Now remember, logarithmic functions have vertical asymptotes. Okay? The only way that vertical asymptotes move is left or right. So if the function was shifted left 1 unit, our vertical asymptote was also shifted left 1 unit. So my vertical asymptote, I'll abbreviate here, started at x equals 0. If it's shifted left 1, it's now at x equals negative 1. Okay, second one. So again, parent function is just going to be log base, whatever we've got here, so log base 3 of x. All the other numbers correspond to other transformations. So the 4 in front of the log, right, this would be a vertical stretch. And the plus 5 here, okay, if it's not inside parentheses, then it is going to be a vertical translation. So if you look at the example on the left, that x plus 1 was contained in parentheses. That's what gives it away as being a horizontal translation. If you don't see that, like we have for the second one, the plus 5 is going to be a vertical translation up 5 units. So since we didn't have any horizontal translations, it wasn't moved left or right at all, that means the vertical asymptote hasn't moved. Okay, the vertical asymptote is going to stay right where it was for the parent function, which is at x equals 0. Now, just like for exponential functions, right, I said we're just going to plug it in, graph it, look at the table, and plot some points. We're really doing the same thing here, okay? It is very, very smart to find your transformations, to find your vertical asymptote, so that you can visually check and make sure that your graph is lining up with all of this information that you know you should see happening. You may have to use your change of base formula, okay, depending on the calculator you have. So I will show you how you can type that in. I'm not going to actually graph it, but I'll show you how you can type it in. Let's say we had, log base 2 of x. I didn't spell log correctly. Hold on. Okay. Your calculator only has log base 10 built into it. If I want to graph log base 2 of x, I need to use my change of base formula. I can graph log of x divided by log base 10 of 2. Those are the same thing. So that's your workaround for how you can graph those logarithmic functions in your calculator. All right, everybody, that is it for this video. Let me know if you have questions. Have a wonderful rest of your day.